So let's get started. So this is the code where we have our library declarations over here. We declare the IEEE standard logic library, and then we have our entity here. This is our input and output declaration. Here we have the A and B as inputs and C as the output. We are going to put A and B to get C. And in our architecture, this is where we put in our process or concrete code. Let's type in some basic code. So we'll say C, we'll put A and B. Okay. Don't forget the semicolon. Okay, so what this will do is we'll take our A and B and output will be C. If you want to know what the output will be, you can take a look here and look at the AND gate. So we are expecting our output to be 1 only, and A and B are both 1. Okay, so let's test this in simulation to see if we are correct. Now, before we can begin our simulation, first we need to create a test bench, which is basically a code which we can use to fill in our inputs and monitor our output. So go to add source, create. Okay, next, create file. We are gonna call this and TV. Yeah, okay. Okay, yeah. So click finish. Okay. And the partner is yes. Okay. Okay. Normally you can write it yourself or you can write your own test bench, but I prefer to copy all this code. Control C, and then we go online and we look for a test bench generator in Vhdl because we're just testing some simple codes. I like to use the 1 by doubles. This take that code, select and Control V into there, and then you click generate Vhdl to our test bench. Yeah. And there we go, we got our test bench. So select from over here down to end, and then copy that, Control and C. Go to our test bench, delete all those, and then copy our code into there. Okay. And become, and if you press Ctrl S, you can see that this become the parent of our AND gate. So this is the input to our AND gate. Okay, so let's write some code to stimulate our block over here. First, let's initialize our input. So what I did over here, as I said, okay, if we put a logical 0, let's put that into A. Now we copy that and put it into B, also making at time equals 0. A must be 0 and B must be 0. Then Control S, save it. Okay. Save. Okay. And now Control S. So okay, run synthesis. Okay, this is successfully completed. Then I'll cancel it. Wait. Good. Try run simulation. Ayan. Let's see what we got. Okay. There. So when A and B are 0, we got nothing as output. Okay. So let's see. So now we are testing combination of A and B. So then to see what the output of C will be in any case. Ayan. Okay. And there you go. Okay, control zoom in. You will be able to see some individual flip-flops and logic gates or lookup tables. To see exactly what's happening, let's go to schematic. So this is what we generated from our code. A and B code for buffer, and then goes into our lookup table, and then it gets buffered out and output as C. That is it. There is a lot more that you should go through. That will only go through the main concept that we need to get going as quick and simple as possible. Okay. And that's all